Right, now this is just a quick introduction to Kicad, because I want to just show you around Kicad so you understand kind of what all the components are before we go through any kind of tutorial. Because it's one of the things is when you first start working with programs like this is that it's difficult to kind of understand the associations that are going on. So I've got a project open here on the left, which is my mushroom controller. Now all this does, it has a couple of 7-segment displays, and it has some buttons and some relays, and some sensors, and it controls temperature of heating elements via the relays using the temperature sensors for a feedback loop. Now, so there's a whole load of files here, and then that looks a little bit intimidating because there's so many files, because Kicad is made up of a bunch of kind of closely coupled, or loosely coupled I guess, programs, and they're kind of individual programs. There's a bit of kind of Unix way style thing going on there. Now, so let me just explain what all these things are. In this Gerbs directory, these are actually my Gerber files. This is the end product of creating a PCB with Kicad. This is the output. So these are the things I would send off to the PCB manufacturer. You know, this is my copper mask for the bottom, or actually my solder mask, my copper layouts of where the tracks are for the bottom layer, the silk screen for the bottom layer, the edge cuts, that shows how big the board actually is, so where the PCB manufacturer should cut the board, my copper for the front, the tracks that are all over the front, the solder mask for the front, and the silk screen for the front. So that was generated after I'd done everything. Okay, I realise I'm going a bit backwards here, but you know, just bear with me. Now, this one, the SCH file, that's the schematic. Now the schematic obviously is a logical layout of your PCB. So this is just diagrammatically represented. And the schematic is, there's a program called eSchema. So that's the program that you use to generate a schematic. That's the first thing you start with. Well, you start by designing your project on a breadboard or something like that. Or you could do it directly in this. And then you copy it into a schematic. I'll show you that in a second. Once you've generated your schematic, you then generate a netlist, which is kind of an intermediate format for your schematic. That is then used by this by a program called CVPCB, which associates components in your schematic with components on a PCB, and that's the actual PCB file, which is generated by a program called PCB new. Right, so this will make sense in a minute when I go through it. That's just a text file that happens to be in this directory to do with my bill of materials, and that's a library that's got some specialist components in that didn't exist in the default libraries, and you can edit those. So there's a bunch of programs here. There's eSchema, that allows you to edit your schematic. There's a schematic library editor, so you can add new components, schematic components that is. You then got PCB new, which once you've done your schematic, associated it with footprints, you then generate your PCB, and then you move your footprints around and connect them up with wires using that. There's a PCB footprint editor, so you can create new footprints for components if they don't exist. I'll explain what footprints are in a minute. There's something for viewing Gerber files, and then some other things which I never used, which are bitmap to component, PCB calculator, and PI editor, PL editor, worksheet layout editor. Okay, you're going to kind of have hierarchical worksheets if you've got very complicated projects. So let's dive straight into the schematic. So this is the schematic for my mushroom controller. Now this is one of these are shift registers, and I've got a chain of shift registers connected to 7-segment displays. So there's 2 blocks there because there's 2 readouts. So there's 2 4-digit readouts. This isn't a very efficient design. I could have used multiplexing and a single shift register, and you can buy these in blocks of 4 that have all 4 segments on, and you multiplex between them. There's lots of different ways you could do this, but I wanted to do it this way because this is the first PCB I made, and I liked this design when I did it on a breadboard, and I wanted just to to take that through because it's quite a complicated design, so it provides a good learning experience. Now this is the chip itself, which is an ATmega 328P AU. these are all my connectors. These are 2 blocks of switches here for connecting up for controlling the display, you know, for changing the set point temperatures and things like that. And you can see kind of how you wire things up with a schematic. So in the case of this switch block, you've got the VCC is like a label to say that that's the voltage source, in this case 5 volts, but that can be, effectively that can be any label. I could have labelled that, you know, 5 volt power supply, because you can, what the schematic editor does is create what's called nets, and nets are connected elements. So VCC is actually a net name, or a special net name, because it's a power symbol, because there's kind of design rules checking built into the schema editor, which allow you to you know, check the electrical sanity of your schematic. And so there are special labels, like power labels, which are involved in that checking process. But essentially they are just labels. So all of these, anything that's labelled VCC, this will tell the schematic eschema, the schematic editor eschema, that these are all VCC. So they all need to be connected to VCC, all these points. And here's another label here, which is SWB1, switch block 1, to represent that switch block. And if I go over to my CPU here, you'll see that switch block 1 is actually there. It's connected to pin 25 of this chip. So I don't need to physically like draw a wire. I can draw a wire by pressing W and like draw a wire all around. You know, I don't have to do that between switch block 1 and the actual switch block, because I can just write a label, and then eSchema will know that this switch block is connected to that pin via this wire. So you know, that means you can do your schematic in a way that's the layout is kind of easier to read, because you've not got crazy wires everywhere, because you know you're going to have lots of crossing over and all kinds of crazy things when you try and put that on a PCB, and you don't want that in your schematic, because the schematic you're supposed to be able to read. You have to forgive me, because I did lay out the 7-segment display chain in the same way I laid it out on the PCB, just because it was complicated to do, and I'm a newbie at doing this, so that's what I did. Now, so what you'll see is, now one of the things you need to, with Kicad, it uses a lot of keyboard shortcuts. Now, these are very, very easy to remember. Well, they might be, I don't know if they are for me. You don't have to use them. So say I wanted to add a new component on here, I could go place component, and it shows you some of the things there, like Shift A. Actually, this is the shorter ones than that. You can just press A, and it comes up with a list of components, for example. You can zoom in and out with F1 and F2. It's good to remember, like learn some of these keyboard shortcuts. You can actually find out what they are just by looking at the hotkeys, list current keys, and it will show you what they are. So add component is mapped to A, for example. Now, you will learn these, and then they're very useful. So say, for example, I wanted to, you know, add in something else in here, an LED or whatever. I could just like press A, add in an LED. There we are, I've got an LED. And if I wanted to connect, put a resistor in here, maybe I need a 4.7k resistor. I can add in a resistor, just press A and then R. W for a wire, connect that up. Maybe this LED is just connected directly to VCC again. So click on P for power, choose VCC, put it in there. You can rotate it around with R, connect up a wire with W, and then maybe this just goes straight to ground. It's like some insane thing. It's pretty insane. So P again, ground, shove in a ground, and then W again for a wire, and there we go. I can then edit also this. So say I want to say the field value of this, say I want to say it is a 4.7k resistor to remind myself, and so on. Now what you'll notice is, when I added in this resistor, it's got an R here and a question mark, and this LED, which is a diode of course, has got a D and a question mark. Now eSchema does this automatically. So if I add in another resistor, I can just copy this, for example. You'll see that they all have they all have an R question mark. Now this is so that you don't have to manually label each of these resistors so that eSchema knows that they're different. What you do is, once you've created everything and connected everything up, you click Annotate Schematic Components, you annotate, and you'll actually see that now these resistors have actually got numbers, R17, 18, 19 and 20. So you create all of your, just let me delete all this crap. So you create all of your schematic, and then once you've done all that, you put all your components in there. Okay, while I say that, I'll just quickly say, like, if you wanted to add a new component in there, you could actually go to the component editor. Where is it? Library editor, and you could, if I set the current library to, I'll do another tutorial to make this obvious, but I'm just wanted to show you something. So, right, say I wanted to create a new thing in here. I would do new. Now, one thing about Kicad is sometimes things are not in the menu, which is a little bit strange. They're sometimes on the toolbar. I think they're fixing this up. I've noticed in the newer versions, most things are also then in the menu, but sometimes you have to do things in the toolbar, which is a little bit annoying. But say in the library editor, I wanted to create a new component, and it's going to be some like weird transistor. I would then be able to edit it here in the component editor, and it would have this designation here, U, but say I wanted it to have a weird designation like weird transistor question mark. What I could do is then create the layout, for example. It looks like this. Let's say I can add pins to it. Pin 1, which is, let's say that's my ground or whatever. Sorry, that's wrong way around. And maybe it's it's got a collector. Why would it have a ground? Let's say that's the emitter. And then I could add another pin for the collector, pin 2, and oops, sorry about this. Collector pin 2, and the base, right? For a transistor, that's what it has. Right. Anyway, so I could do that. I could then save this, and then I could actually use this component back in the component editor. So I could look this up. I could add a component, choose a component, add it back in. Gremlins, eh? And like here's, for example, some components that I created in my mushroom library. I could save this one in there, and then it would appear in here, and I could use it in my PCB, in my schematic layout. Now, so once you've completed your schematic layout, what you then want to do is you annotate all the components, make sure they're all annotated, they've all got names. Then you generate what's called a netlist. This is just an intermediate format. You do this, you just generate it, and it saves it. It will tell me to save it over there. That's it. Then I've generated my netlist. That's used by this program CVPCB to associate components and footprints. Now this is just a schematic, but in a PCB we need actual footprints which show what the physical component is going to look, the copper traces of the physical component is going to look like on the PCB. And that can be different for a lot of things. So what we'll do is we'll take an example. If we look at this power supply, this converts between VCC and 3.3 volts. So our output here is actually 3.3 volts, which is labelled there. It's got a couple of capacitors, decoupling capacitors, and a diode to stop, dissipate spikes that occur on this side. Now, let's take a look at, say, C12. This is a decoupling capacitor. If I click on CVPCB to associate components and footprints after I've done my schematic, Ignore that. That's just a problem with my setup, which I'll fix. Then I can find C12 here, and you'll see that it's associated. What this means is that it's associated with a surface mount 805 package component. Now, the schematic, all it knows about that capacitor is that it has 2 pins. That's all it knows, you know, because that's all it knows about that capacitor. Now, and this field value I've given it, you know, but it doesn't know what those 2 pins should look like on the PCB. For example, I might, if I was completely insane, actually be connecting, plugging a capacitor into a pin array, like a header pin, a 2x1 header pin, if I was completely bonkers. I'm not, of course. I'm using SMD pads, and I'm soldering an SMD 805 package capacitor onto the board. But I might have a through-hole capacitor, you know, in which case, you know, there's a whole bunch of stuff. If I click on the left here, I can associate this particular capacitor C12 with any of these footprints, because, you know, you get different components. Like, you can get very, very small SMD components, you can get through-hole components, and if you're going to create a PCB, you need to know, you know, which components are associated with, which footprints are associated with the components in your schematic. Otherwise, you can't actually make a PCB, because there's no information there to create it, right? So in this case, I've got all of my capacitors associated with 805 package SMD. Well, it's an SMD 805 footprint. Now, there's tons of built-in footprints, and you can build your own footprints. So you've got to do that for all of your components in your schematic. You've got to associate them with footprints. Sometimes I am using pin arrays, in fact. Like, for example, I've got a breakout for a power header, which is a 2x1 pin array. I've got a breakout for my 5-volt power. I've got a serial header, and, for example, various other things. Also, for example, yeah, this shift register is a TSOP 16 package, which is an SMD package with 16 pins. And, you know, that's what I looked on Farnell, you know, you look on DigiKey, whatever, find the component that you're going to actually use on your PCB, and find what package it comes in, and then you choose that here. So once you've done that, and you've associated footprints with all of your components, you would then click on Run PCB New to lay out a printed circuit board. I've actually done this already for this design. I will do a future tutorial where I go through doing this, but I just wanted to do a quick overview so you get an overview of all of the components involved. Now, remember our friend C12, the what's that over there? We're looking at C12. The capacitor C12 in this part of the power that goes between 5 and 3.3 volts. Well, in the PCB there, I happen to know where it is. Here is the low dropout regulator, and C12 is there. And so now you can see that is the footprint. If I look at here and look at if I go to the footprint editor, you'll see that the footprint for C12 is this. This is 805 SMD footprint. And I've used that for all of my resistors, my diodes, and all of my capacitors. And here, for example, is the footprint for one of the shift registers. And the footprint contains, if I go to the footprint editor, obviously contains the position of all the pins. These will be the copper pads on which you solder it onto, and some other crap like naming and so on. So it's actually very easy also to create a footprint. You know, if I needed to create a new footprint, I could go to the footprint editor, create a new. Now you always have to choose the active library. So say I wanted to choose it in my mushroom library, which is one that I've got a custom one for the project. Create a new footprint, and I'd call it Crazy Transistor or whatever it was. I had to resist writing Crazy Tranny there. I could create my crazy transistor, and maybe the footprint is like totally insane and it's like some weird triangular thing. That's silk screen, so that's just printed on there. And okay, I don't want that, just let me remove that. And what I can do is I can add my pads on. So maybe this batshit transistor has like 3 pads, you know, like it has 3 through-hole pads, and you can do all kinds of things like change the size of the pad or whatever. So, for example, if it had a 1mm hole in it, you know, let's just say it's some really weird thing, I could do that. And I can also give the pad the number. Now that number will correspond to the pad in our crazy transistor. That, for example, pad 1, that will then correspond to pin 1 on the schematic. So you can create a footprint, any kind of footprint, anything you want, that, you know, is associated. Well then, and I could then select that footprint for my crazy transistor. And I could put that then on my PCB. I could go back in here, and when I import the netlist, it will appear on the PCB. So that's what you do actually. I didn't tell you that, but once you've created your association with CVPCB, you then come into the PCB new, and this will be blank to begin with. You go Tools, Netlist, Read Current Netlist, and you select, and that will just read in the netlist that was generated by that association program. And what will happen is all your components will appear on here, all of the footprints you selected, and they'll appear here typically in a massive jumbled mess. There's a way to like just spread them out sort of randomly, but they won't be connected up. Then of course you have to connect them up, and you've got the tools in there to connect them up. Like, you know, if I wanted to connect up, if we go to C12 again, and we know it's connected to that pad, if I would just delete that track, for example, for now, I can go here and select the track. Sorry, that's the wrong layer. Green's the wrong layer. Here the layer is selected. If I choose the front layer, I can then build a track from there to there, and those things are connected. And what you'll see is, if they're not connected, it knows that that has to be connected. Because if I do a design rules check and list unconnected, it will say, look, that is not connected to ground. So, and you'll have what's called the rat's nest, which is all these wires like this, that white thing, which when you first do this, it will just be covered in that rat's nest. And what of course you want to do is connect up all of your things until you can run the design rules check, and you get no unconnected things. So everything is connected. So when you first import the netlist, you just have a bunch of footprints on there and shit tons of rat's nest everywhere, and then you need to lay these out and connect them up. It's really cool because, and this is a 2-layer board, and what you see is if I just mess around with the layers here, I can turn off my front layer and show you the green, which is the back layer. Now to get from front to back, use what's called a via. Now in Kicad this is very simple to go from the front to back layer. Now say I was drawing a wire here, it's completely bonkers, but I could go along here, I right click, place through via, and now I've gone to the back layer. So if I wanted to connect, for example, to that ground, and then go through, and so there's a ground on the back, ground plane on the back, for example, and then go through and connect to something over here that needs a ground, it's as easy as that. So it's all very simple to actually do. Once you've laid out your PCB, check the design rules and so on, you can do things like add a copper pore. Now this is actually very, so for example on my ground plane, all that, if I've just made the copper pore visible, but what this will do is it will create all of the, it will fill in anything on the back, any extra space with a pore of copper, and it will attach all of your ground elements to that big area of copper, which is good for sort of dissipating noise and so on in your circuit. And that's kind of an important thing. Once you've done all that, you've got your circuit ready, you then go to plot, and you plot an output, and you choose a load of all these, what you want to plot on there. You know, do I want to show the values of resistors and things? No, I don't in this case, just the references, because I've got the schematic. You do that and it generates the Gerber files. Now the Gerber files are actually the thing which you use to you send that off to the PCB manufacturer, and they will manufacture your PCB for you. Now, the Gerber files, what's quite cool is there's something called GerbLook, and this is a website, and I can choose my Gerber zip on GerbLook, and it will actually render the Gerber for me and generate this, so I can actually then have a look at what the PCB will look like. So that's what the PCB will look like on the front and on the back, and it will you can see my big copper pore, and that's what the top copper will look like. You know, that's what the tracks are. And so it just generates all that for you, and that's the bottom copper with the big copper pore, and you can see all the grounded elements are then connected to all this, which is just all copper. Show you the solder mask, like, you know, where the soldering pads are, so where you know you don't want to, you need to leave those exposed, right? So because you're going to be able to solder onto those, the bottom solder mask, and on the bottom you'll just see all of the through hole components and stuff. And then the silk screen for the top, which is all of this will be drawn on with a kind of special pen, and you can actually see that on the PCB, and it will tell you, it will show you, oh yeah, that's my, you know, TS4, oh yeah, I need to solder that component on there or whatever, and there's nothing on the bottom. So once you've done that, you can then send that off to somebody like Hackvarna, for example, and get your PCB made. So it's actually very straightforward to use Kicad once you get used to it. I will do some tutorials in the future where I go through this in more detail. What I will say is, if you want to start using Kicad, I would advise that you use the version out of BZR. So, you know, out of the Git repository, well, it's not, it's a BZR repository, but you know, from the latest development version, the latest code from their code repository, because it seems to work a lot better and so on. And there's really good instructions on Linux just on the Kicad website for compiling it. It uses CMake, it compiles very, very easily. You know, there's no problem as long as you install all the libraries it depends on, and then you can just install it and use the latest dev version and update it whenever you want. And I would advise you to do that, because I've messed around with different versions that come bundled on various operating systems, and I found that the best version is the latest version. It's the most stable and everything. You might have a problem with the default library tables, but what I'll do is, when I do a tutorial, I will make sure I show how you can get like the default libraries and stuff. But briefly, in case you get some errors when you install it, because you might get this anyway, depending on what operating system you install it. There's actually, what Kicad actually stores it in the library lookup in something called the FP lib table. There's a kind of machine-wide one somewhere, like user local share Kicad or FP lib table or something. But there's also this one, which it looks up, and what you'll see is that actually each of the lib table is just some sort of, it looks like some kind of weird Lisp type layout, but you know, it's just bracketed, basically nested brackets, and each library has a name, a type, a URI, options, and effectively the URI is the main thing here, and the name and so on. And KaiSysMod is an environment variable there, and so that needs to be set. In this case it's user local share, I think. But if you hear, when you're like trying to use Kicad following someone's tutorials or whatever, and you see problems with the FP lib table, which you might see because they changed over to this recently, and it's like, I don't think some of the installation methods on certain operating systems have really understood that this happens, you might need to generate this. You know, but it's easy to generate, and once you know that all it is just a table that's pointing to each of these mod files, which are actually the legacy files which they've changed. But anyway, I'll go into that when I do a proper tutorial about it. But for now, well, thank you for listening, and I hope that was at least illuminating of what Kicad can do.